Welcome to AI Frontiers. Today's episode explores cutting-edge advancements in artificial intelligence, focusing on three critical areas: reasoning capabilities in large language models, the emergence of autonomous agentic AI systems, and breakthroughs in AI explainability. These topics are synthesized from 15 research papers published on May 15, 2025. The presentation will highlight key challenges and breakthroughs, with particular emphasis on reliability, interpretability, and human-AI alignment, the fundamental requirements for deploying AI systems in real-world applications. Computer science. Artificial intelligence continues to evolve systems that mimic or augment human intelligence across various domains. Current research addresses both technical benchmarks and societal implications, with particular focus on three key challenges: dynamic reasoning in complex environments, coordination among multiple AI agents, and ensuring transparency in decision-making. Critical questions being explored include how to align AI systems with human values, establish trust in AI-generated explanations, and manage unpredictable emergent behaviors that may arise from increasingly autonomous systems. A dominant research theme emerging from these studies concerns persistent gaps in reasoning capabilities of large language models. Wang and colleagues demonstrate that while advanced prompting techniques can improve performance, fundamental deficits in spatial reasoning remain unresolved. Their work suggests that simply scaling up model parameters cannot solve these core limitations. Meanwhile, Win and team reveal surprising cultural variations in common-sense reasoning performance, with a counterintuitive finding that smaller open-weight models sometimes outperform larger proprietary ones in specific contexts. Agentic AI represents a paradigm shift beyond traditional modular systems, as demonstrated by Sapkota and colleagues. These autonomous systems dynamically reorganize themselves to solve problems collectively, exhibiting collaborative behaviors not explicitly programmed. However, this increased autonomy introduces new risks, including hallucination of false information and unpredictable emergent behaviors that challenge existing oversight frameworks. The research highlights the need for new approaches to control and verify these increasingly sophisticated AI systems. Explainability remains a critical challenge for trustworthy AI deployment. Rawal and team's AX framework represents a significant advance, enabling detection of fairwashing, when models generate plausible-sounding but misleading explanations for their decisions. This is particularly important given the difficulty of evaluating explanations without ground truth data. Complementary work by Xiao and Abdelmahi demonstrates how knowledge graphs can ground AI outputs in structured data, providing more reliable foundations for explainable systems, especially in high-stakes domains like healthcare and criminal justice. Key findings across these studies reveal several critical insights. Strategic prompting techniques can narrow performance gaps between differently sized models, as shown by Wang and colleagues. Sapkota's work demonstrates that while agentic AI enables powerful collaboration, it introduces coordination risks requiring new solutions. Yang's research proves offline reinforcement learning's viability for critical infrastructure applications. Cultural context significantly impacts reasoning performance according to Win's findings. Finally, Rawal's AX framework represents a breakthrough in evaluating explanation quality without ground truth data. The methodological approaches in these studies each present unique strengths and limitations. Prompt engineering offers low-cost performance enhancements but doesn't address core reasoning deficits. Retrieval augmented generation reduces hallucinations but depends heavily on knowledge-based quality. Multi-agent simulation enables complex decision-making but demands significant computational resources. Offline reinforcement learning provides safety advantages but is constrained by historical data limitations. Knowledge graphs offer structured representations but require labor-intensive validation processes. These trade-offs highlight the multifaceted nature of contemporary AI research challenges. The seminal paper by Wang and colleagues makes important contributions to understanding reasoning in dynamic environments. Their innovative adaptive prompting techniques, including self-reflection and heuristic mutation, reveal that while larger models generally perform better, spatial reasoning remains challenging regardless of scale. This work's significance lies in its call to move beyond static benchmarks, demonstrating that strategic prompting can partially compensate for model size limitations in certain reasoning tasks. Sapkota and team's work establishes a crucial taxonomy distinguishing traditional modular AI from emerging agentic AI systems. Their research demonstrates how agentic AI enables collaborative problem-solving through dynamic reorganization, representing a fundamental shift in system architecture. However, this flexibility introduces risks of unpredictable emergent behaviors that challenge existing control paradigms. The paper provides a valuable roadmap for designing explainable, scalable agent systems that balance autonomy with reliability. Rawal and colleagues' AX framework addresses one of AI's most persistent challenges, evaluating explanations without ground truth. Their information theoretic approach detects when models engage in fairwashing, generating convincing but inaccurate justifications for decisions. This innovation is particularly valuable for high-stakes applications where explanation quality directly impacts trust and safety. The framework enables users to more effectively assess when AI output should be trusted or questioned, advancing the field of explainable AI. Future research directions emerging from these studies point toward several critical areas. Hybrid architectures combining symbolic and neural approaches may address persistent reasoning gaps. Cultural adaptation mechanisms are needed to align AI systems with diverse human norms, as highlighted by Wynn's work. Safe deployment requires advances in offline reinforcement learning for critical systems. Agentic AI demands new oversight frameworks for emergent behavior control. Enhanced evaluation metrics must better capture real-world impact beyond technical benchmarks. This presentation was synthesized using advanced AI systems, content generation by a GPT model DeepSeek Chat, text-to-speech conversion through Amazon Polly, and image creation using Stable Diffusion. While human experts reviewed the material for accuracy, potential oversights may exist despite these quality control measures. The synthesis process demonstrates both the capabilities and current limitations of AI-assisted research analysis. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive preprint server.